Welcome to the Explainer. Today, we're diving deep into one of the biggest mysteries in artificial intelligence. How does a machine actually make sense of our world? It all comes down to a concept called representation. And believe me, it's the key to pretty much everything, from self-driving cars to the magic of language translation. So let's kick things off with a little puzzle. How in the world does a computer know that the Turkish word for truck, kamyon, is conceptually really close to araba, which means car, but at the same time, it's completely different from ateşkes, the word for truce? I mean, to a machine, they're all just letters on a screen, right? Well, maybe not. The answer to that puzzle is all about this idea of representation. And probably the best way to get our heads around it is to picture a ladder. We're going to climb this ladder together, step by step, from the simplest ideas all the way to the super complex methods that are powering the AI you and I use every single day. All right, let's start at the very bottom. Our first rung on this ladder is the most basic kind of representation there is. It's called atomic. So, in an atomic representation, every single concept gets its own unique, indivisible label. That's it. There's no internal structure, no smaller parts to it. It's kind of like an entry in a dictionary. The word truck is just, well, truck. The system has no idea what a truck is, only that this label exists. A perfect way to picture this is with a single set of GPS coordinates. You have a specific point on a map, and it's represented by a unique pair of numbers. That point is an atom. It's a single, whole thing. There's absolutely no information inside that label about what's at that location or what's anywhere nearby. And that leads us straight to the big problem with this atomic approach. If every location is just its own distinct label, how could a self-driving car possibly figure out if two of those points are near each other? The simple answer is it can't. For that, we need to add another layer of complexity. So to solve that problem, we have to climb up to the next rung on our ladder: factored representation. With a factored representation, we're not just using one single black box label anymore. Instead, we start to break a concept down into a fixed set of attributes or features. So we're not just labeling something, we're actually starting to describe it. And this is what solves our GPS problem. Instead of one atomic label, a location is now factored into two distinct attributes: its latitude and its longitude. And suddenly, a machine can compare these values. It can actually calculate the distance between any 2 points. It can finally understand the concept of nearness. Okay, so that's really useful for describing individual objects. But what about understanding how different objects relate to each other in a really complex system? For that, we need to climb even higher, to what's called structured representation. Now, structured representations are a huge leap forward. Think about it this way. We went from a simple list of labels to a list with some descriptive details. Now, we're building a full-on city map that actually shows all the roads connecting everything. It's all about modeling the relationships between things. And this is where AI starts to get seriously powerful. It uses things like relational structures, kind of like a database, and these things called semantic networks that explicitly map out how things are connected. For example, it can define that a wheel is part of a car. This lets the AI model the world in a way that starts to look a lot like our own complex reasoning. But to get back to our original question about language, and to really understand the magic behind modern AI like ChatGPT, we need to reach the very top of our ladder. This is the real game changer. This is the breakthrough of distributed representation. The core idea here is a complete and total shift in thinking. Instead of putting a concept into one single box, that concept is now represented as a pattern of activity that's spread across hundreds, sometimes thousands of different dimensions. A word is no longer a single point. It's more like a cloud of meaning. So how does this help us with our Turkish words? Well, in this crazy high-dimensional space, concepts that have similar meanings are placed close together. The position, or vector, for kamyon, truck, will be mathematically very near the vector for araba, car, but really, really far from the vector for elma, apple, and even further from ateşkes, truce. The AI doesn't know what a truck is in the way we do, but it knows what a truck is like. The advantages of doing it this way are just incredible. The AI can now generalize.
It can make intelligent guesses about words it's never even seen before, just based on what its neighbors are. And because the meaning is all spread out, the whole system becomes way more robust and resistant to noise or errors.
And this is where it starts to feel like actual magic. You can literally do math with concepts. If you take the vector for king, subtract the vector for man, and then add the vector for woman, you end up remarkably close to the vector for queen. This is unbelievable. It shows the AI has actually captured these abstract underlying relationships of gender and royalty all on its own.
Okay, before we wrap up, there's one last really crucial concept to get our heads around, because it's not always about just using the most complicated method you can find. There's a fundamental trade-off we have to understand.
This chart really shows the essential trade-off in AI. As we climb that ladder, from atomic all the way to distributed, the expressiveness, the power to capture really complex meaning, it's skyrocketed. But all that power comes at a cost. The more expressive and powerful the model is, the less efficient it becomes. It needs massive amounts of data and computational resources to run. So I think the most important thing to take away from all this is that there's no single best representation in AI. Not at all. The right choice always depends on the specific job you're trying to do. A simple task might just need a fast, efficient atomic label. But to understand the deep, subtle nuances of human language, you need the incredible power and cost of a distributed network.
And that leaves us with one final, fascinating question to chew on. As these AI representations get richer and more complex, as they move from simple little labels to these vast, high-dimensional clouds of meaning, what does it truly mean for a machine to understand? Thanks for joining us on The Explainer.